Hello everyone, my name is Ankit Verma and today we are learning non-deterministic finite automata. It is also called NFA or NDFA. Here we have the finite automata, which means we are having the finite set of states. And finite automata is divided into two parts. The first one is DFA, which means deterministic finite automata. So here in the figure, let us suppose that we are on the state Q0 and here the input A is coming. Then we are moving to the next state, which is Q1. This is DFA because here we know that if we are on the Q0 state and if A is coming, we has to go to Q1. It is deterministic because the move is already defined. The second type of finite automata is NFA, which is non-deterministic finite automata. Here in the figure, let us suppose that we are on the state Q0 and if A is coming, then we are going to the Q1, or for the A we can go to Q2, or for the A we can go to Q3, or for the A we can go nowhere, which is phi. This is NFA. That means non-deterministic finite automata. Here it is non-deterministic because we cannot determine if the A is coming, we can go to Q1, Q2, Q3 or nowhere. That means nothing is fixed. The first thing about the NFA is NFA may contain multiple next state or single next state or nothing for a specific input. So in the NFA, if we are on the state Q0 and if A is coming, we may move to the multiple next state just like Q1, Q2, Q3, or we may go to the one next state, let's say it is Q1, or to nothing, that is phi. So we are reaching nowhere. But in the DFA, for a specific input, we can only go to the one next state. So in DFA, if we are on Q0 and if A is coming, for sure there is only one move possible, which is Q1. So DFA has only one move for a specific input and NFA may have one move, multiple move or nothing. Next thing about the NFA is it contains null move, and null move is represented by epsilon, which means state will change without input. Here the meaning is that in the NFA, if we are not providing any input, even if the state can change. So NFA accept null production or null transition, which is epsilon. But DFA do not contain null move. So in the DFA, if you want to go to the next state, the input is required. For null move, it will not go to the next state. Next thing about the NFA is they are not real. The meaning is that they are more hypothetical because for a single input, we can go to one state or the multiple state. So in the real life, this is not the possibility. NFA are used to observe all possible solutions of a problem. So if we have given with the problem and we want its multiple solutions, then we need the NFA. The next thing about the NFA is that they are easy to construct than the DFA. So for a specific problem, we can design NFA very easily, but DFA designing is slight tough. In DFA, for an input from one state we can go to only one next state. But in NFA, for a specific input we can go to the multiple states or one state or nowhere. That means DFA is the part of NFA, or we can say that every DFA is a NFA. But we can also convert NFA to DFA. So NFA can be translated to the DFA. NFA contain 5 elements. The first element is Q, which means finite set of states. Second element is sigma, which is input alphabet. Third element is Q, which is initial state. Next element is F, which is final state. Next element is transition function. So here we have learned the finite automata is of two types, deterministic finite automata and the non-deterministic finite automata. NFA can have multiple next state or one next state or nothing. So here for a specific input from Q0 we can go to one next state or multiple or nothing. But DFA only have one next state. For a specific input in the DFA we can go to the only one next state. Next is NFA contained null move, which is epsilon, but DFA not contain null move. NFA are not real because in the real life for an input we cannot go to the multiple places, whereas DFA are real. NFA are designed to observe the multiple possible solutions of a problem. NFA are easy to construct and NFA can be translated to the DFA. Every DFA is a NFA and the NFA has 5 elements, which is finite set of states, input alphabet, initial state, final state and transition function. To understand the NFA, I am taking one example. Construct NFA which accept set of all string over sigma equal to a comma b that start with a. So here we are going to design an NFA which will accept all string which start with a. We have given with sigma equal to set of a comma b. Here a and b are symbols and sigma is alphabet. Here alphabet is set of symbols. The meaning is that from symbol A and B we are going to construct the string which start with A. So here sigma is the input alphabet which is the element of NFA and this is represented by sigma equal to A comma B for this specific question. Now from this alphabet we are going to generate the language. So here I am taking L. This L signify language and the language is strings which start with A. There are various strings possible, so that will be equal to the set the single A, it start with A, or double A, it also start with A, 3 times A, here also start with A, 4 times A, 5 times A, B, B, it also start with A, B, A, it also start with A, and so on. There are various strings possible which start with A. For this language, now we are going to construct the NFA. In NFA, we always have a initial state and that is represented by the circle with the incoming arrow. So here I am taking a circle with the incoming arrow. This is the initial state or the start state. I am giving the name of this state is Q0. So here in the NFA we are having element which is Q, which signify initial state. So Q is containing a set in which we are having the initial state and the initial state is Q0. So here in the set I am mentioning Q0. Whenever we are going to construct the NFA, the shortcut method is we have to see which string is of shorter length. So out of all the string, A is of shorter length. So I am picking this string. Now from the initial state, if A is coming, then we are going to the next state. So from Q0 we are going to the next state. This A is the part of language and this A should be accepted by this NFA. That means after getting A from initial state, we should be on final state. So here F signifies the final state, which is represented by the double circle. So here when we are on Q0 and if A is coming, then we should be on the final state represented by double circle. I am giving the name of this final state is Q1. So here in NFA we are having the element which is F, which is set of final state. So here F is having the set of all the final state, and here the final state is Q1. So in the set we are having Q1. So if A is coming, so from initial state for A we are going to the final state, and this is accepted by the NFA. So till now the skeleton of NFA is created. Now we are moving forward and taking another string. So let us suppose that this A is coming. So we are going to modify this NFA. So for the first A, from initial state Q0, we are going to Q1, and for the next A, so we are on Q1 and here A is coming. We know that these two A's are also part of language, so they should be accepted by the NFA, means after scanning the complete string, we should be on the final state. So for the next A, we should come back to the final state, which is Q1. So for the first A, Q0 to Q1. For the next A, coming back to Q1, we are on the final state. So here 2 times A is also accepted by the NFA. In the similar manner, if 3A is coming, for the first A, Q0 to Q1, next A, Q1 back to Q1, next A, Q1 back to Q1. So this string is also accepted by the NFA. So in the similar manner, 4 times A and 5 times A will be accepted because this is a loop. Now we are taking the next string and modifying this NFA. So let us suppose that first A is coming. So from Q0 we are on the Q1. Now the B is coming. So the idea is string start with A and we already got A. So if A is coming or B is coming, doesn't matter. We should accept that. So here I am putting comma B. That means for the B we are coming back here on Q1. Then for the next B, again we are coming back to Q1. So this is keep on repeating because once we get A in the start, so if A is coming or B is coming, we should accept it. So this string is accepted by the NFA. In the similar manner, if A is coming, Q0 to Q1, then B is coming, Q1 back to Q1, then A is coming, Q1 back to Q1. This is also accepted by the NFA. This NFA is ready. We can see that it is different from DFA. In the DFA, every state must have transition for the input symbol, but in the NFA it is not required. In the NFA we can see that at Q0 we have the transition for A but not for B. That is possible because NFA it is not required. That's why NFA are easy to construct. In the NFA we are having the element which is Q, that signify finite set of states. So here the Q is signifying the set of all states which are there in NFA, and here we can see that there are 2 states which are Q0 and Q1. So these are the 2 states which are representing Q. In the NFA, all states are coming under capital Q and the initial state is coming under small q and final state is coming under F. We can see that the initial state is the part of set of all state. So we can say that the small q is subset of capital Q. Also, the final state is the part of set of all state. So we can say that F is the subset of capital Q. The next element is transition function, and the transition function signify if we are on some state and some input is coming, what should be the next state. So here the transition function, we are representing the states which are Q cross the input which is represented by the alphabet. So we are going to the states, and those states can be 2 raised to the power Q. So first of all I am taking the Q, which is set of states. So here the states are Q0 and Q1, and cross with the input alphabet, and the input alphabet are A and B, and they can give 2 raised to the power Q. The meaning is that 2 raised to the power Q. So here are 1, 2. So that means 2 raised to the power 2, it will be equal to 4. So there are 4 possibilities. So I am taking a set here. We are having the states, we get some input, and we are having the possibilities here. The first possibility is that we are going to nothing, because in the NFA it is possible that we are going nowhere, which is represented by the phi. The second possibility is that we are going to the Q0. The third possibility is that we are going to the Q1. And the fourth possibility is that we are going to both the states, which is Q0 and Q1. So that is represented by same Q0 and Q1. Because in the NFA, we can go to the nowhere, represented by phi, single states, which can be Q0 or Q1, or multiple state. So here 2 states are there, that's why I am taking Q0 and Q1, which signify multiple states, means both the states it is going. Now I am going to multiply these two. So first of all Q0 with A and B. So first of all Q0 with A. So here I am representing Q0 comma A. Then Q0 with B. So representing Q0 comma B. Then Q1 with A. So here Q1 comma A and Q1 with B. So Q1 comma B. And here on the right hand side we are having the possibilities, which is nothing, represented by phi, or Q0, or Q1, or both the states, which is Q0 and Q1. So here we are going to provide the transition. So for Q0, that means we are on the state Q0, and if A is coming, then we are going to the Q1. So from here we are going to Q1. The next is Q0 B. That means we are on state Q0, and if B is coming, here we can see that the move is not defined. That means it is going nowhere, and the nowhere is signified by phi. So here I am putting to the phi. Next is Q1A. That means we are on state Q1 and A is coming. So we are coming back to Q1. So for this I am putting towards Q1. Next is Q1B. So I am on Q1, and if B is coming, we are coming back to Q1. So here arrow is going towards Q1. This is the transition. Now I am going to create the transition table from this transition function. In the transition table, we are having the present state, next state for A, next state for B. So first of all, on the present state, let us suppose that we are on Q0. Here I am mentioning the arrow. This arrow signify initial state because this Q0 is the initial state. If A is coming afterward, so from Q0 we are going to Q1. So here I am mentioning Q1. And if B is coming, so from Q0, move B is not decided. That's why it is going nowhere, which is phi. Now the next state, which is Q1. So here I am putting the Q1. This Q1 is the final state. That's why I am putting the star here. So from Q1 present state, if A is coming, then for A we are coming back to Q1. And from Q1, if B is coming, then again we are coming back to Q1. So this is the transition table. So we have designed NFA and the transition table for the language where string start with A. So that's all for today. Thank you.